Hello everyone, welcome to this lecture. And in this lecture, I'm going to discuss what is the best case, average case, and worst case in an algorithm. So let me jump into this. So it defines in order to analyze the solution of any problem, we have to understand three cases: best case, average case, and worst case. Okay, and to understand these cases, we have devised a problem. We have considered a problem. Consider given array of random elements. Okay, we have to categorize best, worst, and average case. In this example, searching of an element is done. Okay, so what we have done is, so we have given an array like this. We have given, let's say, we have taken 10 elements, and just an array is there, like what we are used to see. I'm just writing that down. We are used to see elements like this, and let me quickly write it down. Okay, so I have to determine what is the best case. The question is, I have to search an element. So what is the best case, or what is the basically the definition of best case of an algorithm or a program is, I cannot take lower time than the best case in order to do anything in my problem, or in this case in my array. So what is the best case to search an element? So the best case is, if I'm searching, if I say search 5, element 5, then it is at the index 0. It is at the first index. So I cannot take less time than this to search an element. So best case is to search the first element. Now the second, I will take the worst case. I'm not taking the average case. I will discuss the average case after this. Now, what is the worst case? It is just the opposite of the best case. It means I cannot take more time than, if I decided 10 seconds is the worst case of this uh, program to run. This program in any condition should not go beyond 10. And that is the situation we are aiming for. So if I am going to search the last index, if I say search 4, so what it will do is, it is going to linearly search. First it will go at index 0, it will check 1, then 2, like this. It will go on and check the last index, and the last index I'm going to find my number 4. So search the last element. And in this case, the worst case, I'm going to again more precisely define. If I can also say, this is also not the worst case. Why? If I am going to search, let's say, let me search 100 in this array, the number 100 in this array. So we can see there is no number 100 in this array. So the number 100 is not found, and I'm going to search this array 11 times. Because on the 10th time, I'm searching the last index element, and I will not find the number 100, and I'm going to search it 11 times. So if the number itself is not found, then that is the worst case. So I have to run 11 times through this array. Now, what is an average case? Now, when we say to define average case, most of us, most people get confused how to define an average case. So first, let me put a statement out there. We cannot find average case of all the problems. Okay, we may find a best case, we may find a worst case, but we cannot all the time find average case of all the problems. So in this case, what is the average case, or what is why we cannot find average case of all the problems? It is because uh, to find average case, we have to do all the permutation and combination uh, possible for a particular problem. Okay, we have to do all the permutations and combinations. So it may not be always be possible to do all the permutations and combinations, but we may take a wild guess, or we are just we are that is why also we are just interested in the worst case only. Okay, because the worst case, we imply that that is a average case, or we may consider our worst case to be our average case when we are not able to find the average case. Okay, so in this situation, any element between the first index and the last index we are finding, and that amounts to be the average case. Okay. Okay, so in this case, we may say that if there are 10 elements, and if we found anything at index 4, or at n by 2 index, means just at the middle, and that considered to be an average case. Okay, we may say it like this. Now, one more important thing, ho- what how we are calculating this best, worst, and average case, by seeing the number of comparisons made. Okay, see, for example, when we did search 5, we did one comparison. Okay, and when we did search 4, we did 10 comparisons with 5, 7, 9, 12, 15, 1, 8, 10, 6, 4. Okay, and when we searched 100, we did 11 comparisons. So the 11th part was not there, so we exited. Okay, in average case, we did half the comparison. Okay, so this is what basically best, worst, and average case is. And moving on, and let's understand why we need to find this best, worst, and average case, and why we considered the worst case to be the most important case. Why we why we are so adamant in finding the worst case only. We are not considered about the best case for sure, and average case also. Suppose I'm giving you a situation. We have Amazon dot in India, and suppose there is a festival of Diwali. So in normal days, let's say there are 10,000 people coming on the website regularly. But on Diwali, this is definitely going to increase. Let's say 10 million people are coming on Amazon. And just hypothetically, I'm saying, I do not have any facts, but the ratio is definitely going to increase on Diwali, because there are many offers to go, and there will be much more people buying things to gift someone. So we need to find how many servers are needed to cater to these 10 million. So this 10 million is considered to be the worst case scenario for which Amazon.in has to be prepared. Okay, it has to be prepared for that. So that this is the reason. Otherwise, if they are not prepared for it, if 10 million people come and they do not have server for it, the site is definitely going to crash. Okay, so that is why we have to find this worst case in anyhow, and depending on this worst case only, we have to devise our plan. We have to find the solutions. We have to take steps to cater situations like this. Okay, so this is it. So thank you for watching this video.